Greetings, fellow friends of Euclid. This is Mr. Vangerud, and this is the first geometry video for the year. And this is a little matching exercise. This is vocabulary that comes from the introduction in the first lesson. And I'm going to suggest that just as a little exercise for yourself, why don't you pause the video right now and see how many of these you can match up. It's not a graded thing or anything, just for your own sake, just see if you can figure out which term goes with which definition. So why don't you pause it and just make some mental notes or write down on a piece of paper or whatever you want to do, just to see how you do, because that, I think if you try to do it in advance before you are told what it is, I think it helps you think about it and remember it later, and that's always good. So go ahead and pause it and see if you can figure these out. Okay, welcome back. Let's see how you did. Deductive reasoning, that's the kind of reasoning that we use in geometry. There's a little section in the book about compares deductive reasoning to inductive reasoning, and you'll use a lot of inductive reasoning in your science class, and deductive reasoning is what we use in geometry mostly. So this is F, deductive reasoning. That is a method that uses logic to draw conclusions from statements already accepted as true. You find that we do this, we prove statements throughout the course, and we can use previously proved statements to prove the new statements, and that's deductive reasoning. Well, if that's deductive reasoning, then what is inductive reasoning? Okay, so it's a different kind of reasoning, and you see there's, if you look at C, a method used for drawing conclusions from a limited set of observations, and that's inductive reasoning. So you're observing and recording and drawing conclusions in inductive reasoning. In deductive reasoning, we're following a path of proof, that we're taking previously proved statements and using them to prove new statements. All right, and what is a point? Well, this is right out of the book. In our book, we describe it as H, that which has no part. And that is not a definition. You know, it's actually just a description. How about a line? If you look at the remaining definitions, also right out of the book, also not a definition, but a description, having breadthless length. You know how we draw a line. I wasn't thinking I was going to be writing on here, but you know, we draw a line and to indicate it keeps going on in that direction in both ways, both directions. We use the arrows, so that's having breadthless length. So let's see, get that to move. All right, and then what's a plane? Plane, we often use, in describing it, we often talk about it being something like a table, but that's not a very good description. It's a flat unbounded surface, and the thing is, it's kind of like the line. It goes on and endlessly in all directions. So that's a plane, a flat unbounded surface. Line segment obviously is part of a line. And the difference is it's bounded by two endpoints. Sorry about my bad line segment there. But that's okay. So which one is that? That was the first definition there, a part of a line bounded by two endpoints. And collinear points. Remember what co means. It means with or the same, or the other teachers at West are my co-workers. We are working together, the same job, so that kind of gives you a little bit of a hint there with that prefix. And collinear points means that they are contained in the same line, so that would be D for that one. As in Dusseldorf. Non-collinear points, well, obviously non means they're not. It means that then we've got Instead of that, we've got E, which is points that are not contained in the same line. Coplanar, again there's that prefix co, points that are in the same plane, so that would be J. And concurrent, when you concur you agree. Okay, that's kind of how this relates to that, and we've only got B left, so lines that contain the same point. That's concurrent lines. So we could say that these three lines are concurrent. They all contain this point here. Okay, so there is some definition. It's important to just be aware of all the terms as they come up. You're going to find that in this course. The more you can stay on top of the vocabulary, so you know what they're talking about when they start talking about it. It doesn't go away after you've taken that chapter test. You have to keep it in the forefront of your mind. So really make a commitment to know what each of these things, their definitions, each of these terms. The more familiar you are with it, the better off you'll be. This is a class that rewards hard work and preparation and really taking responsibility for the information. So if you're just thinking, I'm going to get the homework done, done with it, get on to the stuff I want to do, rethink that a little bit. You'll do better and you'll be happier about it if you take the time to really become familiar with all the concepts here. Alright, that's it for now. Have a geometric night, and we'll see you tomorrow.